think that is my cue. Okay. Hi, everybody. I'm going to talk to you for the next 30, 40 minutes about architecture and design in the era of agentic AI. Now, before we get into that, if you haven't met me before, my name is Grant. I grew up in Las Vegas, Nevada, and that's still where I currently work remotely. Fun fact, we do have more than just hotels in Las Vegas. We do, in fact, have houses there as well. We also have beautiful outdoors, which is one of the reasons that I still am in Las Vegas. This is a picture of Red Rock Canyon, frequented by many rock climbers around the world. I'm married with 2 dogs and 2 cats. If you ever see me in a Zoom meeting, you're going to see at least one of those pets at any time. If you see me around and you share any of these hobbies with me, feel free to chat with me about them. I love rock climbing, 3D printing, video games, board games, and a few other things that don't fit on the slides. I've been at Carta for over 4 years now. And another fun fact, the first programming language I ever learned was Blitz Basic, which is a spinoff of Visual Basic focused on 2D game development. First program I ever wrote was like a Invader style game that had a memory leak and would crash my laptop if I played it for more than 5 minutes. So, about the actual talk. What do I want people to get out of this talk? I'm going to try to cover 3 topics here. Topic number 1 is I want to cover what it actually means to write good code. I want to talk about how we ensure our agents continue to write good code. And then I want to show an actual visual example, put my money where my mouth is. Let's go and use these concepts that I'm going to talk about in a little Unity game. And we're going to try to vibe code some stuff and see how it works out. But before we dive right into the topics, I do actually want to make some assumptions about all of you, the audience, and all of you up there. First off, I assume that everyone here is a capable engineer. I know, very bold of me to assume, but I think everyone here is genuinely good at their job. I think that's an important assumption to make because part of being a good software engineer is understanding that our field is constantly evolving. The first internship I ever had 10 years ago, someone would hand me a Figma file and I'd make an email out of it. I did that for an entire summer. I couldn't even fathom that being an internship today, seeing what interns at Carta are doing. And part of being good at your job is understanding that those fundamentals change over time. And you should always revisit those as time goes on. We could be in that new situation today with agentic AI. Second, I'm going to assume that everyone here understands the core principles of architecture and design. This isn't a talk where I'm going to teach you about a port and adapter or a hexagonal architecture. You can go find a TikTok that's going to do that 10 times better than I ever could in this 30, 40-minute presentation. Everyone's here done an A&D study before. Many of you have passed this. All of us have done some form of architecture and design. So that's not what this talk is about specifically. And lastly, I think that everyone here cares about the quality of their code. Again, this might sound obvious, but I have a brother. He went to school for 10 years to study kinesiology, and he's a professor at Utah Tech now. He writes code almost every day, but he couldn't give 2 flying shits about the quality of his code, and there's nothing wrong with that. Code for my brother is a means to an end. He needs to analyze a data set, or he needs to visualize a gate analysis for some dumb running study of his. But for him, it doesn't matter. Code is like this ephemeral thing that exists one day and is tossed out the next day. But for us, that's our entire jobs. We care about the quality of our code because the code we write could be used next year, 5 years, 10 years from now. And I'm assuming that all of you want to care about the quality of your code, whether it's you writing it or maybe an agent writing it on your behalf. So, what does it actually mean to write good code? I think an easier place to actually start with everyone is, what does it mean to write bad code? I think it's a lot easier to come to a common agreement on what bad code is before we get to good code. So, here's a nice little snippet we have here. We're going to process an investment transaction request. Now, I have my own reasons why I think this code is terrible, and I think it's pretty atrocious. But does anyone in the room want to throw out some fun fact of why they think this code is terrible? Or on Zoom, I can repeat you as well. Local imports, good one, Brian. Didn't even think of SQL injection, but of course, Vamsi from security would know of that one, for sure. A lot of magic numbers, mysteries, too many things, separation of concerns or lack of, tons of stuff going wrong here. Here's one thing, we have no schema validation. We're just loading in the request body. You better pray that the front end is doing the right thing, and it's gonna forever do the right thing, because otherwise you're in for some crazy undefined behavior. We're just passing configuration information directly into our SQL cursor or our Redis instance. That's not going to be very fun when you have to change your local environment settings. And lastly, I don't think anyone here understands what this business logic is, not even myself. Like, what's the 7th column of the fund, and why is it 0.85? What's all these things going on with the SQL statements? I don't think it's a stretch of my imagination that everyone in this room and on Zoom can probably agree that it's pretty terrible code. And it's not just because it's written in Python, Dan. And why is it terrible code? Like, what's a common trait that is with all of these critiques that we're talking about is like, one, could you understand this code? Maybe if you wrote it, you could, but anyone else is going to have a really tough time understanding it. Could you maintain this code? Again, maybe if you wrote it, but it's really difficult to understand what's going on and what happens if the front end changes. There's all these like caveats that you have to take into account. And then could you extend this code? I don't know. The business logic is so messy. It's like, how do I know that I'm extending this code to do new things without breaking the old things? And I kind of spoiled it already, but I think the common trait that all these share is that bad code is hard to change. Doesn't matter if your bad code is using some cool DDD concept or hexagonal architecture. If your code is really hard to change, in my opinion, it's bad. And there's extreme examples like this, and there's less extreme examples of over-engineering that still make your code hard to change. So if we take that and we say, okay, bad code is really hard to change. So what is good code then? To me, I think good code is easy to change. It's a really simple principle, but it works. And I think a lot of fundamentals boil down to this aspect of like, we want our code to be easy to change in the future because we don't know what's going to happen in the future. We have all these tools today, like layered architectures, and microservices, and hexagonal architectures. I don't think good code means you need to be like a zealot of layered architecture. Like you have to always enforce a layered architecture, or you need to be some like czar of microservices where like you can't do anything unless you build a new microservice to go get the birthday of somebody, and then you have all these other issues. I think good code just means using the tools that you have as an engineer to produce code that can be easy to change. So it could be controversial to say this, but I think while these architecture patterns are good and they can create good code, they in of themselves are not indicative of good code. It is the output that you can produce to create code that is easy to change in the long run. You might be like, okay, Grant, that's a pretty reductionist mindset to think about. Like, isn't that hyperbolic that like nothing matters? It's just code needs to be easy to change. And yes, I do agree with that statement, but I also think it's a really good mindset to have, especially as we talk about this next topic of agentic AI. Because if you think about what all of these principles boil down to, it helps you focus on code that might not be your own that we're autonomously producing in the future. Let's look at some like standard software principles. Separation of concerns. We do this so that we can isolate our business logic from our database logic, from our presentation logic. Why would we do that? It's because we need our code to be easy to change. You might need to update how you store something in the database without changing how you return it from the front end. And that's an important concern, and it's so that your code's easy to change. Dependency inversion. Now, we don't do this a lot in Python, but for Java devs, you're probably well aware of this principle. It's the ability to create applications that are loosely coupled around interfaces or contracts, not directly inheriting from other dependencies. Why would we have dependency inversion? Well, what if we need to swap out our database provider or switch to a different caching provider? It's to make our code easy to change. Single responsibility. It's this idea that an object in an object-oriented language must only have one responsibility in the system. Can't have two, can't have three. It's one responsibility. Why do we do that? Probably surprising to no one at this point. It's because we need our code to be easy to change. If you have one responsibility, it's easy to test it and isolate it and change that code without affecting other parts of the system. So a lot of these principles, in my opinion, all of these principles boil down to the fact that if you can come back to your code a year or 5 years from now, understand it and change it easily, I would consider that good code. Doesn't matter if it's following a specific principle, doesn't matter if it's coming straight out of Martin Fowler's blog, it's good code to me. So here's the same snippet, but a different version of it. Would I consider this good code? Absolutely. Would I consider this perfect code? Is it the best code? Probably not. But could you understand this code? I think compared to the previous snippet, I would claim that a lot of you could probably understand this code, if not everybody here. We have a schema that we're loading in at the top. We have pretty clear business logic, and we have an explicit return from our method. It's much, much easier to understand. Could you maintain this code? I also think you could, because you now have all of your business logic pulled out into separate methods that you could test and change without being worried about other parts of the system being impacted. And could you extend this code? I also think you could, because the place in which you're performing your business logic is in a very well encapsulated place. So by virtue of these principles, I would consider this good code. As you can notice, there's no crazy DDD or object-oriented abstraction we're doing here. We're just making the code easy to change. So hopefully by this point, I've convinced you at least a little bit that good architecture and design is the ability to produce code that's understandable, maintainable, and extendable over time without needing to go in and perform surgery every time you touch that code. So if we take that understanding, how do we apply this to this new era of agentic AI? How do we make sure our agents are doing this? Here's an image I ripped straight off of Google. It's the history of artificial intelligence. And this slide is really just to show you that AI isn't necessarily something that's brand new to us. It's been around for 50 plus years. But in the last 5 years, we've gone from GPT-3 to Gemini 3.5, multimodal agentic programming. We've seen this Moore's Law explosion of AI improvements in just the last 5 years. And what does that mean for us and our engineers? It means that our craft is fundamentally changing right now, and we have to understand what is our job going to look like in 5 to 10 years? In the same way that 10 years ago, my whole job was converting templates with Figma designs. What does our job look like another 10 years from now, and how does that change? For one, producing code objectively is easier and faster than ever before. Note I said producing. Whether that code is good or not, up for debate, but you can't argue that you can produce code faster than you've ever been able to before. That's important. We also have this concept of we already have high-level programming languages, but how about a higher level programming language? Prompts are now becoming this new higher order programming language that we're thinking and talking about of should we also be reviewing prompts and the output they produce, which is the code that we also then review? So there's this new aspect of our career of prompts are becoming more important as time goes on. And we're just delegating more work to agents. That's just a fact. A couple years ago, you could maybe try to use AI to fix a table on a front-end page, or if you were super advanced back then, you could do some business logic stuff. But now, I had a 4-hour flight yesterday. I connected to the plane Wi-Fi. I gave it a prompt. I turned my screen off, and I just let the laptop go for 4 hours to produce some prototypes of stuff. The amount of work that you can delegate to agents today is crazy compared to what you could do a couple years ago. What is that going to look like in another 5, 10 years? And how do we make sure that if our hands are off of the keyboard, not writing as much code anymore, how do we make sure that these agents are doing things that we need to and writing good code along the way. So we need to make sure that our agents don't give us this. We need to make sure that they give us the other aspect or something greater or something more advanced. And a part of this talk could objectively be me talking about skills and subagents and superpowers and a lot of these other cool tools. There are plenty more qualified people that are going to talk about this stuff, and it is one aspect of trying to solve this problem of agents writing good code. But it's not a part of my presentation. I'm going to leave this to some of the more experts that are going to talk about this, and you should go to these talks because they're going to be really cool. Well, I want to talk about some of the fundamental things to think about whenever you talk to an agent. Like, how can we encourage agents to write good code? I think there's two things I really want to focus on in this presentation: precedent and its interfaces. So precedent, if you think back to like what an agent is, like agents are really good at finding patterns in code today. A very dumb way to think about an agent is it's like a Markov chain for your phone text messages. When you open up your phone and you say, hello, and you see that recommendation for the next word, that's a Markov chain. I think it's Markov. But that's existed for decades. But agents take this to another level, and it's an extremely complicated, sophisticated version of a Markov chain. But agents are capable of finding patterns and dimensions that humans are incapable of seeing in the code or the tokens that it consumes. But what does that mean? It means agents also, at the same time, they don't understand the nuance behind decisions that have been made in those code and the patterns that have come to be. So every company that has ever written a single line of code has technical debt. That's just a fact. Like, there's no such thing as a company with a perfect code base. But like, technical debt is not the result of like some malicious engineer sliding in bad code over time. It's us doing our job. Like, it probably starts as a prototype. It becomes wildly successful. It now becomes the core part of the business. And now you suddenly have technical debt. It just happens. But agents, when they look at those patterns, they don't understand the decisions that led to these patterns that exist in the code today. Maybe we're not super happy with the corporation model having, 56 mix-ins, or maybe we're not super happy about the partner repository being in the place it is today, but it's there for a reason, and it's because we're doing our jobs and we're trying to solve problems for the business. And that means that agents are capable of exacerbating bad code by following those patterns when they're producing new code. And that's something really important to recognize, is you can apply agents to areas with what you might consider bad code, but if you're not prompting it correctly, it's only going to make the situation worse over time. On the flip side, though, agents are also good at producing good code when they're surrounded by good patterns and they're provided good precedent. So in the same way that an agent can exacerbate bad code by using bad patterns, an agent can encourage good patterns if you give it the right tools to understand what those good patterns should be. So let's say I say precedent is important. How do you take that and apply it to your everyday work? How do you apply precedent in a prompt today? A couple things I'd recommend is, if you don't know, commit hashes are a really cool tool for providing context to a prompt. If you have a specific feature and something similar has been done before, you could always just go find that pull request. We squash all pull requests into one commit when we merge them. And you can just send that commit over to the agent and say, hey, I liked how this was done. Please go look at this commit SHA and go do the same thing for this current plan. We did this with health checks. Leandra and I had to build some new pulse checks for the financial reporting system. We asked Kevin for a good example of how one was done before. We took the merge commit and we gave it to Claude, and Claude built like incredibly well done health checks for us with little to no work. Being able to use commit hashes, if you haven't yet, would highly recommend it, especially for related features or extensions. Direct file references is probably no surprise to anybody here. But more so than just referencing files for context, you should also consider referencing files of good patterns. If you're in an area of code that you might consider heavy with technical debt or with bad patterns, you can totally give it some context at the end and say, by the way, go read the patterns that exist in this area of the code base or this file, and apply that to the current plan. Because again, AI is good at finding those patterns, and it's good at taking that context. So don't treat file references as just things that have to be relevant to the current task. You can also give it files just to go understand the structure of those patterns and try to apply them to new areas of code. And lastly, example snippets. If agents are great at finding patterns, you can always just give it the pattern directly in your snippet if you need to. This is actually, I think Anthropic itself is very bullish on providing specific code snippets in their prompts. Like Claude is great at this. If you want it to use a specific layered architecture approach, give it a snippet, and it'll be able to take that and apply it to your prompting for your plans. That's precedent. The other piece is interfaces or contracts. And this piece is a little bit more nuanced, but I also think it's extremely important. So again, agents, they're great at adapting to the language of your domain. If you've ever prompted an agent and mentioned the word fund administration, you'll notice that it replies to you as if it was always aware that this is a talk about the fund admin domain. It's great at like code switching into the domain that you're talking to it about. But at the same time, if you've ever tried to actually ask it to do things in that domain, it really needs guardrails to work within it. That previous snippet I showed you of like processing an investment request, like there's no such thing as like a capacity request. Like it just made that shit up. Like it thinks it's a fund admin, but if you're not giving it the proper guardrails to work within that domain, it's just going to make stuff up. So an important part of interfaces is giving agents strong interfaces to interact with your code base in a way that it can build solutions by working with those interfaces, not trying to reinvent the wheel every time it goes to solve a problem. So strong interfaces give agents the tools they would need to build solutions, while weak interfaces are going to expose these leaky abstractions that we have in our code base, and they're going to give agents way too much control, and they're going to go off the rails and do crazy things. So a big thing that I want to emphasize is use strong interfaces in your domain. The single most important part of this piece is just don't give agents access to your persistence layer. If you have a query set, like guard that like a dragon guards its gold. Do not let agents ever have access to your query sets. Because what it'll do is if you have a service method that gives a query set as a return type, that agent now has full control to mix up the query set, grab models from it, update, delete. Like you've just given it full access, keys to the city, and it no longer needs to use any of your service interfaces that might have important business logic contained in them. So above all else, make sure that you're properly abstracting persistence from business logic. Like I said, don't expose. Separation of concerns is a really good practice to encourage here. Same with single responsibility. You want to isolate code so that agents have fixed contexts and environments to work within, and they don't have to go figure out how to reinvent the wheel based on some database model they've ended up getting their hands on. Second thing, pulling out some DDD lingo here, is adopt a ubiquitous language. A ubiquitous language just means a language that everyone agrees upon. At least that's what I think of it. You want to design interface methods in your services that describe what your actions represent, not what they're doing. I think a really common mistake or something that I'd recommend against is when you have a service and let's say you want to mark something as resolved. Maybe the engineer in your brain is thinking, I don't want to repeat myself, so I'll just create a generic update status and timestamp method, and I can mark something as resolved by passing in 2 values to that method. Works great, reduces code, but at the same time, if an agent is looking at your service and it sees this method and it knows it needs to mark something as resolved, it still has to take like 2 more mental leaps to get to that understanding that marking something as resolved means calling this method with these values. Whereas, alternatively, what if you just had a method that said mark resolved? What if an agent's looking over your service and it sees a method called mark resolved? It understands immediately without more work that, oh, I can just use this method. And I don't have to go like figure out or derive how to achieve this behavior based on like standard engineering interfaces that we might think about. So like highly recommend when you think about your domain, think about what those actions represent a trick I like to test myself with is like, if I could send my service methods over to my product manager and they understand what those things are doing, that's probably a ubiquitous language. But if I send my interface method of update status and timestamp over to my PM, they're not going to know what the hell I mean. And that probably means an agent might not have as great of an idea of what you mean as well. So I think in summary, I really want to stress that like agents are only as good as the contracts and the precedent that you've set before. And so far I've been hand waving a lot at everybody here. Like these are principles that you should follow. But I'd also like to convince you with hopefully a fun example here. So if you saw that last slide of about me, you know that the first language I ever learned was a game development language. I have a bit of a side project where I'm working on a video game right now called Monked. The game is a castle defense. You have to defend against enemies, and they're going to try to kill all your villagers. So you need to protect them. But let's apply these principles that I've just talking about, and let's go build a new enemy in my game. And we're going to vibe code it. So I've got my archer here. We want to create a new archer for the game. This archer needs to spawn and then approach a waypoint in my castle. That archer needs to shoot at villagers and the player as it sees them, ideally in a cone of detection. And it needs a fixed amount of HP because I need to be able to kill this archer. So let's try first with no interfaces, no contracts, no precedent. Let's just tell Unity, hey, here's my prompt. I need you to go design this. I've included as much context as I could. I need you to design and implement a new enemy archer variant for my game. Now at the bottom, I have an important section here that says you cannot use any existing abstractions or patterns in the codebase. You must implement this enemy variant from scratch, and it must entirely reside in your mono behavior, which in Unity is like a self-contained script that runs on an update cycle. I set this up in the inspector in Unity, and I gave it every component and dependency it needs to go build an AI agent. So all I needed it to do was implement that behavior and that state inside of a class. So I ran this prompt through, and let me share my results with y'all. And we'll walk through how it did. There's no sound, so don't worry about that. Here we are in the game. I've selected a boon. Here's my monk. Here's my lovely archer. He's not doing great. He is not doing so great. Doesn't seem to be animating very well. And then I'm going to try to kill him right here. Also does not seem to be going that well. So, it's a one-shot prompt. Maybe there's a couple things to work on. But to highlight this one-shot prompt, like what went wrong, very weird projectile spawn. I don't know why Unity is shooting it from there. Also, no firing animation, just shoots, doesn't even attempt to aim or anything. And I gave it all of the animation hashes it should need to play animations. It was not targeting our villager, which it should be. It was only shooting at me and not doing a good job of it either. And I also couldn't even deal damage to the archer too. So there were some clear issues with the no interfaces, no precedent approach here. So how about we try again? And this time, let's use contracts and interfaces. So I now have, thanks, Matthias. I now have this abstraction system. This has existed in my game already. I've been working on other types of enemies. So I have this enemy abstraction that can contain target detectors, which look for cones in front of it. There's a state machine implementation that allows me to build enemy states like idle, chase, attack, fear, and dead. So what if we actually tried to leverage the interfaces that we have in place today to go one-shot an enemy now? Same prompt as last time. It's a little cut off at the bottom because my tab is stuck at the top, but that is no problem. But the important part, again, is this time I've said, use existing abstractions and patterns in the code base. Implement this enemy variant using the ranged enemy base pattern, which inherits from the enemy base class. So now Claude is going to go look at these classes, learn about how they function, and it's going to go try to leverage the existing interfaces that we've designed for it. So let's see how we do now. same story. We spawn in, we've got our monk. And would you look at that? Our archer is aiming. He just killed my villager. He's aiming much better this time. The arrow is coming out of the correct location. He does walk a little bit weird, but that's okay. And we should be able to also kill him. Lovely. His hands are doing some weird things here. We can fix that later, for sure. But again, first try. Much better, right? Like this time around, what did we manage to do? We're shooting from the right location. We're spawning from the weapon. That's awesome. We also have a firing animation now because our interfaces allow Unity to quickly understand, or allow Claude to quickly understand that, like, oh, we need to play a firing animation when we enter this state. So it's much easier for Claude to figure this out. It also killed our villager. Not great for us, but great for the enemy and for the prompt. And we can also kill it, which is awesome. And these were 2 prompts, virtually identical with different important sections at the bottom. One was to go off and try to do this yourself. One was try to leverage existing interfaces that we've tried to build to enforce like strong architecture and design patterns for enemies. So yeah, why'd the second prompt work so well? We included precedent through direct file references, and we provided strong interfaces for the agents to work with. So, closing thoughts here. Topic number 1, what is good code? Like, in terms of what I hope that everyone here can walk away from this presentation with, I want you to think about good code being code that is easy to change. Bad code is hard to change. Think about those core principles. Like I said, I assume everyone here is good at their job. You have the discretion to make the changes and use the tools you need to encourage good code and bad code. Again, 8 architecture and design principles. They're your toolkit, not your gospel. You want to use them. Most architecture patterns and principles are there to make your code easy to change. Leverage them when you need to, but understand what they exist for. Topic number 2, once we can distill good and bad code down, how do we make sure that agents write good code in the future? Very important to provide precedent in your prompts. And what that also means is we need to create precedent by evaluating our own code, especially now more than ever. Think 10 years from now when agents are autonomously creating code, we need to have that precedent built up in the code base so that the patterns agents are capable of looking for are good patterns that we can encourage. And enforce strong interfaces in your code. When you're looking to design a new service or you're just modifying an existing service and you see an opportunity to leave things a little bit better than they were before, focus on guardrails for your services and repositories. Don't think so much in the context of like, oh yeah, but engineers will know what I mean when I name it this. Think about it in the context of like, will an agent understand what it's going to be able to do with this method when I provide it in this service? And last one, evaluate PRs with agents in mind. I think this is kind of like an unspoken thing, but when we're looking at code and we're looking at design patterns, think about how agents will interact with that. Think about the worst case scenario. It's even more of a worst case than what we might originally think of as like, oh, what could an engineer misconstrue about this? Now there's this other aspect of, oh, what could an agent misconstrue about this? And we need to be capable of allowing our agents to work in our code base in the future without us fearing the tools that we've given it. All right, everybody. I hope you enjoyed the talk. That was all.